Here's my report on using serverless functions to create a loosely coupled system. Let's take a quick look through the setup in the AWS console. Beginning, we have the two new roles in the Rosetta Hub, IAM roles for the total notifier Lambda transaction and the transaction processor Lambda function. This was set up with 3 CloudFormation scripts, one for the Lambda, one for the S3, and one for the Dynamo databases. We have 3 Dynamo databases, a transaction total, which you can see we've already run the transactions, so it's been populated. We have 24 transactions in the database, and we have 2 customers. In S3, we have the one file that we loaded. The 2 lambdas that are set up, the transaction processor acts on any inserts into S3. The total notifier acts on records that are written into the transactions Dynamo database. There are subscriptions to the SNS topic for the high balance alert. You can see there are 2 SQS subscriptions and 1 email inscription to myself. And if you look at SQS and the queues, there are 1 message on each queues. Let's look at the scenario I've used for this assignment and see how it meets the goal of demonstrating how serverless functions can be used to build loosely coupled systems. Let's look at it for high availability. It's highly available because it is built using small, distinct steps. Information is buffered in intermediate locations such as the S3 bucket and the DynamoDB tables, and then in the SQS queues. It's highly available because it uses S3 as a front end. That's an excellent choice for keeping the front end available for customers to download transactions and insert data into the system. It's a single piece that's independent, and as long as S3 up, even if the Lambda functions are down, you can get data into your system. This design is highly performant because it uses AWS managed solutions that are built to be scalable and highly performant. You can add capacity to individual solutions as needed. Best practice, use monitoring to make informed scaling decisions. The system is fault tolerant by being built in many small steps. It prevents cascading failures. If there's a failure in one step, you can recover from that intermediate step. Like if the data makes it into Dynamo but doesn't get through the Lambda function, you can fix the Lambda function and rerun it from the Dynamo table. A lot of this flexibility is based on the use of microservices. Small changes to microservices reduce risk of overall system failures. The cost model is pay for what you use. You'll spend less during periods of low demand. You'll spend more during periods of high demand. Security is part of S3 and Lambda. In S3, best practice is to restrict access using bucket ACLs, apply IAM rules and bucket policies, encrypt the files at rest with a symmetric data key, and monitor access to detect security violations. In Lambda, your Lambda functions use an IAM role, and best practice is to give the fewest possible privileges in the IAM role to the Lambda function. You'll see an example of SNS fanout used from the SNS topic to the notification subscription and the SQS queues. That's a great way to distribute work to independent services. A lot of the benefits you're getting here are from microservices. Those are the Lambda functions are examples. They have minimal code. They're independently scalable. A failure in one service is not going to cause a cascading failure in the other service. The code in one microservice can easily be upgraded independently of the other microservice, and they're communicating through database tables, so you can write each microservice in whatever language you prefer. When adding software features, you've got a smaller testing surface. You've got less features to test. And each service can scale horizontally. In this assignment, I showed an example of an application architecture that demonstrates how serverless functions can be used to build loosely coupled systems. I evaluated my implementation from the perspectives of high availability, performance, fault tolerance, cost, security, and the use of microservices.